Have you ever taken a tablet and wondered how it knows what to do once inside your body? Why does one medicine act fast, while another takes hours? Welcome to Demystifying Drug Absorption, where I dive into the fascinating world of biopharmaceutics. Drug absorption refers to the process by which a drug moves from the site of administration, like your mouth or your skin, into the bloodstream. It's the first and most critical step that determines a drug's effectiveness. So, what influences how fast and how much of a drug is absorbed? Let's break it down into 3 categories. First, physicochemical properties. Solubility. Every drug needs to dissolve first. Lipophilicity. Drugs that love fat cross membranes more easily. And pKa. How ionized a drug is will affect its permeability. Second, biological factors. Your GIPH. How quickly your stomach empties, enzymes in your intestines, and even efflux proteins like P-glycoprotein all play a big role. These can make or break absorption. Third, dosage form design: tablet, capsule, suspension, controlled release. Each one affects how quickly the drug gets absorbed. Here's what happens when you swallow a drug. Disintegration. The tablet breaks apart. Dissolution. The drug dissolves in fluids. Permeation. It crosses the intestinal lining. Absorption. It finally enters your bloodstream. Ever heard of the BCS, the Biopharmaceutics Classification System? It classifies drugs into 4 types based on solubility and permeability. Class 1, high solubility, high permeability, ideal. Class 2, low solubility, high permeability. Class 3, high solubility, low permeability. Class Avor, low solubility, low permeability, the toughest to formulate. Let's connect this to real-world examples. Paracetamol acts fast because it's class 1. Ciprofloxacin, take it on an empty stomach. Food slows its absorption. Controlled release tablets like M.Pharm and XR release the drug slowly over time. But what if a drug has poor absorption? Scientists have workarounds. Nanoparticles and liposomes can improve permeability. Making salt forms or prodrugs can enhance solubility. And enzyme inhibitors can slow down drug breakdown, letting more of it be absorbed. Let's recap. Drug absorption is a complex journey influenced by chemistry, biology, and formulation science. It's the gateway to therapeutic action. Want to test your knowledge? Here's a quick quiz. Which BCS class has the biggest formulation challenge? What's the first step in oral drug absorption? Name a biological factor that affects drug absorption. Drop your answers in the comments, and let's keep learning together.